Hello guys, today we'll be learning about expression of amplitude signal. So last class we had learned about amplitude modulation. So today we are basically going to know about expression of AM signal. As you know, instantaneous value means a value at particular point. So the instantaneous value, the instantaneous value of of message signal is given by m of t. This m of t is usually represent for message signal, means m of t. M is dependent on time t and t is independent. So m of t is basically am, which is maximum amplitude of that signal, and cos 2 pi fmt. So as you know, this cos is a periodic signal. So cos 2 pi fmt is the message signal. So this is the value of particular amplitude point. So where am is maximum amplitude, and fm is frequency. Now instantaneous value of carrier signal. What is the equation of instantaneous value of carrier signal? Let me write it. The instantaneous value of carrier signal is given by so carrier signal is denoted by c of t. So c is dependent on time t is independent. So this will be equal to the AC, that is maximum amplitude of carrier signal, AC, and cos 2 pi fct. As you know, this is periodic signal. So these equations are related. 2 pi fct, where AC is the maximum amplitude of carrier signal, and fc is frequency of carrier signal. So as we know, the standard equation of AM amplitude modulation. So what is the standard signal of amplitude modulation? Standard equation of AM signal, that is amplitude modulation, is given by, so amplitude modulation means, as you know, I had explained in earlier class, is given by this S is given standard equation of amplitude modulation is given by S of t, which will be equal to AC, that is amplitude of carrier signal, and 1 plus K A M of t cos 2 pi f c t. So s- so this why there is one is added to the K A M of t. So suppose this is 0, this is 0, so there is so this amplitude of carrier signal will also be 0 if there is no 1. So we have added so that the amplitude of carrier signal is still existing. Suppose there is no 1, then m of t will be suppose m of t is 0, then AC will also be 0, which will not make sense. So this is the equation for amplitude modulation. And as you know, AC is amplitude of carrier signal, and f of c is the frequency of carrier signal, and k is amplitude sensitivity parameter. So suppose we substitute m of t, that is be equation, I will give the number for the equation. This is 3, this is 1, this is 2. Suppose you add 1 in 3, that is m of t, value of m of t in equation 3. So s of t will be equal to AC 1 plus K A M of t we should add m. Oh, okay, wait. So uh, so you should add value of m of t here. That will be Ka. So value of m of t was like am cos 2 pi fmt. So basically add m of t value, that will be a m cos 2 pi fmt, close the bracket. So this is the value of m of t, close the square bracket and write cos, this one write as it is, 2 pi fct. Now now this you should add as symbol u, where this is known as modulation index, that is Ka and Am, which is known as amplitude modulation index. This is known as modulation index. Substitute in the s of t signal s of t. So s of t will be equal to AC 1 plus Ka Am uh, this you should add as that is this one, modulation index, and write as it is the other equation. plus fmt, close the bracket, close the square bracket, and write cos as it is 2 pi fct. Let it be equation 4. Now multiply AC and cos 2 pi fct. So this will be equal to AC and this one cos, that is one will be multiplied by AC and this, so this will be cos AC cos 2 pi fct, and there is plus sign mu AC cos 2 pi fct into cos 2 pi fmt. So there is a formula called as cos A into cos B. So cos so it will be like cos A into cos B, so it will be basically equal to half cos A minus B, cos A minus B plus cos A plus B plus B. So this is a formula. So applying this, you will get S of t equal to keep this equation as it is, like AC cos 2 pi fct plus, so applying the formula you will get as mu AC by 2 plus cos 2 pi fc minus fm into t plus mu AC by 2 cos 2 pi fc plus fm by 2. So this is carrier LSB and this is USB. Thank you.